Welcome to the Section 7 Marathon. The marathon is the place where every polynomial technique we learned shows up at once. 3 problems, one after the other, each one exercising a different muscle from the section. Multiplication, synthetic division, and finding all roots in that order. Polynomial multiplication walks the distributive property across 2 factors. Each term of the first polynomial multiplies every term of the second, the products line up by degree, and the like terms collapse into a single result. Watch the chain unfold for a quadratic times a linear factor. Synthetic division strips a polynomial division down to its coefficients. The bottom row of the tableau hides 2 answers at once. The first entries are the quotient. The very last entry is the remainder, and the remainder theorem says that same remainder equals the polynomial evaluated at the divisor's root. We will check both and confirm they match. The third problem ties everything together. Factor a cubic by grouping the terms in pairs, then finish with a difference of squares. 3 roots fall out cleanly, and we plot them on the curve so you can see exactly where the cubic crosses the x-axis. Problem 1. Multiply x squared minus 2x plus 3 by x plus 4. 2 factors, the first a quadratic with 3 terms, the second a linear with 2 terms. The plan is to distribute, then combine like terms. Multiply each term of the quadratic by x first. X times x squared is x cubed. X times negative 2x is negative 2x squared. X times 3 is 3x. So the first row simplifies to x cubed minus 2x squared plus 3x. Now multiply each term of the quadratic by 4. 4 times x squared is 4x squared. 4 times negative 2x is negative 8x. 4 times 3 is 12. The second row simplifies to 4x squared minus 8x plus 12. Add the 2 rows term by term. The cubic stands alone. The x squared terms combine to give 2x squared. The x terms combine to give negative 5x. The constant is 12. The product is x cubed plus 2x squared minus 5x plus 12. One sweep of distribute, one sweep of combine, and the multiplication is done. Problem 2. Divide 2x cubed minus 5x squared plus 3x minus 7 by x minus 2. 2 routes will give us the same answer. Synthetic division on the left, the remainder theorem evaluation on the right. The remainder theorem says they must agree. Set up the synthetic division tableau. Write c equals 2 on the left of the bar. Across the top, write the dividend's coefficients in descending exponent order. That is 2, negative 5, 3, negative 7. The bar separates the divisor's root from the dividend. Run synthetic division. Bring down the leading 2. 2 times 2 is 4. Add to negative 5 gives negative 1. Negative 1 times 2 is negative 2. Add to 3 gives 1. 1 times 2 is 2. Add to negative 7 gives negative 5. The bottom row reads 2, negative 1, 1, negative 5. Read off the result. The first 3 entries are the quotient. The last entry is the remainder. So the quotient is 2x squared minus x plus 1, and the remainder is negative 5. That is the synthetic division answer, and it took less than a minute. Now check with the remainder theorem. Substitute x equals 2 directly into the original polynomial. 2 times 8 is 16. 5 times 4 is 20. 3 times 2 is 6. Subtract 7. 16 minus 20 is negative 4. Plus 6 is 2. Minus 7 is negative 5. Both routes give negative 5. The synthetic division remainder and the polynomial evaluated at the divisor's root are the same number, as the remainder theorem guarantees. The match confirms the synthetic division was done correctly. Problem 3. Find every root of x cubed minus 3x squared minus 4x plus 12. The cubic is plotted underneath. 3 crossings on the x-axis are already visible, so we expect 3 real roots. The job is to factor and read them off. Group the terms in pairs. The first 2 terms form one pair, the last 2 form another. Be careful with the sign. Negative 4x plus 12 becomes minus the quantity 4x minus 12. The grouping turns the 4-term polynomial into 2 clean pairs. The first pair x cubed minus 3x squared has a common factor of x squared, leaving x minus 3. The second pair 4x minus 12 has a common factor of 4, leaving x minus 3 again. Both pairs share the binomial x minus 3. Pull the common binomial out front. The polynomial becomes x squared minus 4 times x minus 3. The first factor is a difference of squares. It splits as x minus 2 times x plus 2. The factorization is now complete. 3 linear factors give 3 roots. X equals 2, x equals negative 2, and x equals 3. 3 dots glow on the curve at exactly those x values, right where the curve was crossing the axis from the start. Section 7 complete. 3 things to keep from Section 7. They cover the multiplication side, the division side, and the factoring to find roots side of the same algebra. Distribute every term of the first polynomial across every term of the second, line up the products by degree, and combine like terms. That is the entire algorithm for multiplying any two polynomials, no matter how many terms each one has. Synthetic division compresses polynomial long division to one row of arithmetic when the divisor is x minus c. Read the bottom row to recover both the quotient coefficients and the remainder in a single pass. The remainder theorem then double checks the answer. Factoring by grouping turns a 4-term polynomial into the product of two binomials when the pairs share a common binomial after pulling out their own GCF. Once the cubic is factored, finishing patterns like difference of squares deliver the last roots.